Can you hear me? Can you hear me online? Hi. Hi, can you hear me? Yep, okay. All right. All right, welcome. So we're gonna have the second quiz today. It's all about creating tables. So last week was about designing UML diagrams. This was about creating, which is taking a UML diagram and creating a equivalent table. Also foreign keys, primary keys. I did send a message earlier today. So let's see. Do you already see it on your module? Okay. And if you started, I think it might ask you for a code. So I believe I think it's doc, but let me. Yeah, it's doc. So DOCK. DOCK, lowercase k. And let me put it on the chat as well. Password for the quiz is doc.
answer the first question, and then hit next, and then it prompts me for the access coding in this page.
Oh, okay.
Should I just go back?
Oh, wait, let me.
Yeah, I just got the same prompt.
Oops. All right, try refreshing. I removed the access code. Try restarting it, maybe. Yes, well, it's case insensitive. Doesn't matter. But hmm? Yeah, it doesn't matter. It's case insensitive. No, no parents, no special characters. Yeah. Who's done? Who's not done? Who's done? Who's not done? Oh, wow. Yep.
Okay, I just didn't know.
Yeah, the other one, foreign key references. Yeah, that's correct.
But then this one, I was like confused with what should.
So here are the foreign
this
key
one's
references.
Yeah.
Right. So these will be references.
Okay. Yeah, that's what I thought, but because there's two. Okay, thank you.
And primary key. So the references
To itself,
itself.
yeah.
Yeah. So it would be X, right?
Yeah.
So it would be something R, X, not R. Right? There is an R, is it? Yeah.
No, I just did that.
It would be X. The references R ID. Yeah.
Yeah.
Yep. I'm sorry. Oh, thank you. All right, who's done? Who's not done? All right. All right, get started. All right, so yeah, I've made the answers to quiz 1 available. So please take a look at it. If you see some discrepancy, if maybe you just misspelled something, you have any concerns, I will start a Q1 thread on Piazza, right? So we'll just reply to that, and so just let us know, and the TAs and myself will take a look at it and fix it for everybody, whatever is there. Okay. Now you can assume that if you give us a particular issue about a quiz, we'll fix that issue for everybody, right? All right, so let's continue where we were. Yeah, so last week we were talking about designing and creating databases using the create statement and foreign keys and primary keys. So this week we're focusing more on querying the database, right? So we introduced the select statement, and we saw how we can we can use choose what the fields we want and from which tables do we want. So let's keep working on that. Before we do that, I did want to cover the assignment. Did we cover the assignment on Tuesday? We didn't, huh? Okay, so yeah, let's go with that. So in the assignment that's going out today, you're giving a UML class diagram. This is the same class diagram that you were given prior week, right? In that case, you were creating the tables, creating all that, and so this time around, we're going to give you that. Right, so it's kind of like this is the answer to the previous assignment. We're going to give you the tables, the user table, the reply table, blog, rating, post, and so on and so forth. And we also going to give you how to examples of populating this table, right? So we're going to create a couple users, we're going to create a couple blogs, a couple posts, right? Some dummy data. And then we're going to ask you to interact with it, right? We're going to ask you to retrieve data from the database. The data is, you can download it from this GitHub repository. So if you go there, just a couple of kilobytes, there it is. So you can just click on download. It'll download to your download folder. And I'm just gonna move it into our cs3200 here. And I'm gonna unzip it. Okay, there it is. And in there, there's a whole bunch of SQL files, right? It's basically what you did when you submitted, like two homeworks ago. You exported the database. Well, I did the same thing. I exported it, and now I'm giving it to you. You should be able to just import it into your database, all right? You can blow away whatever database you were using before, right? Whenever you're done with the assignment, you can blow it away, and then you can import this, and we'll go from here on all the subsequent assignments. We'll assume that you have this database on your SQL, or you can just create a new schema and just work on that schema if you want, right? So if you want to preserve the other one. So here's on Workbench. I've already blown away all my tables, right? So I just selected them. I said drop tables, and I said okay, just removed all my tables. Once I'm there, I can use a server data import, and I can navigate to my download folder, PC documents download. There it is, my CS. There it is. So it's a folder inside, right? And that was the one who contains the SQL files, right? So I'm going to say okay, and I'm going to say start import. So it's going to bring in all the. This is how the TAs have been grading you, right? They import your database, right, and then they try it out. And that's why it's important to follow naming conventions and you name certain fields the same way and the certain data types. Otherwise, all their scripts won't work, right? Because they'll assume that you have certain names for the fields. So anyway, so if you refresh here on the left-hand side, you'll see that now we have all these tables. So if you right-click on any one of these and you select on type of select rows limit 1000, it'll just do a select star, right? And we already saw what this is. It means retrieve all the fields from this particular table, right? And it spits out the content. The content, presumably, these are users that are using our micro blogging application. That we have Alice in Wonderland, we have Bob Hope, Tim Dodd, Elon, Charlie, and Daniel. Okay, and we have a couple of usernames, passwords. You would never actually have passwords stored in like this. It would be encrypted somehow. We also have a handle, right? The way it would display on the user interface. Username, password, that's it, right? And then we also have blogs that belong to them. Right? If you do a blog and select, right, we can see that there are a couple of blogs, a couple on space, everyday astronaut, SpaceX, Tesla, Hyperchange, whatnot. Okay, and then we have a couple of posts for them as well. Not many. So we'll be inserting and creating new data, right, and inserting it. You'll be doing that in the next assignment, right, populating this data a little further. But for this assignment, we're asking you to just see if we can just retrieve data from here. Okay, and so it asks you to run through several exercises. Again, all the assignments are, first I show you how to do it, and then I ask you to do it yourself, right? So, for instance, for the first one, we ask you, well, retrieving all the records. And I just showed you an example of retrieving all the records. Is just select star from users. Now, this assumes, right, that you have that schema already selected. Right? If you don't have a schema selected, this will fail. It'll say because it says, I don't know what schema you want me to apply this to, right? So it assumes that you've double-clicked on the schema. Oops. You've double-clicked. I have, right? If you double-click, it makes that schema the default schema. If you do not do the double-click, then you have to explicitly say what schema are you applying this this command to. Make sense? So all the assignments assume that you have that selected, and I believe it tells you to do that. Import blah blah blah. Start import. Double click. Yeah, double click the schema so it becomes the default schema. So this walks you through making sure that you're all set up. Okay. Yeah. So retrieve all the records, and then we ask you to do on your own. Create another one. Now we also say that in front of all the right before every single command, that you should put a comment describing the intent of your query. Okay, so try to, in one sentence, in plain English, explain what this query does. Whether the query actually does that, that's another issue, right? But the paragraph or the sentence should describe the intent of the query. Okay, what you think that query does, right? And then we could discuss or argue whether indeed the query does what you think it does, right? So for instance, this might be retrieves all blog posts. Okay. We also ask you, I believe, these files, right? These tabs were created by Workbench as I did right click and did a select, or would you create a brand new SQL file by clicking on this SQL over here and then just do all your work here, right? And I believe that's what I asked you to do. To do all your work in one single window, right? And just add all your queries to this one file. And then you're going to save this file, and that's what you're going to be submitting as for your deliverable. All right. And every single query should be prepended with a comment explaining what your query does. Right. So in this case, the first one here, notice that it has a comment at the beginning. It selects all records from the users. You can select the line of code that you want to run it, and then you can click on the lightning bolt, right? It'll run it and show it'll show the results down below. Okay. All right, excellent. So then it asks you to do one on your own to retrieve all the content of the blogs table. Okay, that's pretty easy. And to make sure that you put a comment above in front of your select statement, right? All right, so do that. Also, it asks you to save it into a file called querying relational databases. So we're going to do save. Save that. And that's the file you're going to submit as your deliverable. All right, so the next one is, okay, we retrieved all the records, or you can retrieve an individual record by its primary key. If you know their primary key, you can retrieve that individual record. So let's do that. Right, so for instance, retrieving a particular blog if you know their primary key. So we can just paste it there. You can, if you run this, right, it'll execute everything in the file, right? If you don't select any particular spot in query, right, it'll run the entire file, right? So if you have in there, a couple of inserts, updates, deletes, it will run all of them, right? And maybe that's not what you want, right? So be careful, right? You have to select what you want to run, right, and then just run that. Right? Otherwise, it'll run everything by default, right? That's the default. All right, so yeah, so we retrieved a particular blog because we knew its primary key is 2. Okay, that's very, very common. It's very common that we know the primary key of a particular record, we go and fetch it and it retrieves it. Okay, and everything that you see displayed in any user interface, if you go to Twitter and you see any post, any blog, any user, any recommendation, has a primary key associated with it, right? And whenever we do a query and we retrieve those and display in the user interface, usually the application knows that the first post has an ID of 1, 2, 3, and the second one has an ID of 2, 3, 4, and blah blah blah, and whatever, right? So if you want to delete the posts or edit the post, you can always issue a command, delete the post whose ID is yada yada yada, right? So there's most of the communication back and forth between your front end and whatever you have in the back end. Usually there's just a whole bunch of primary keys going back and forth where you want to delete something, update something, or retrieve something associated give me all the replies to this post, right? Then you say, well, you do a select replies where the the post ID is yada yada yada, right? And it retrieves all those replies. Okay, so yeah, it's very, very common that we interact with any records by their primary key. Yeah, so we retrieve one, then it asks you to retrieve a particular post knowing their ID. We can also alternatively retrieve a record not by its primary key, right? Now this one, if it's a primary key, you should always expect that the record, only one record is going to come back, right? Because that's the point of having a primary key, right? There's only one record associated to that primary key, as opposed to if you do a predicate, which is not a primary key, right? So for instance, retrieve a user by their username. Well, the username here, Elon Musk, is not a primary key, but by the name username, probably it's unique, right? That you're not going to have the same username twice, right? So we can run that, and there we go. We have Elon Musk as a user. Well, then we ask you to retrieve blogs whose name is SpaceX, right? So it'll retrieve that one record. That's you're gonna do that on your own. And then joining tables. So joining tables is presumably we split up the data, in our normalization endeavors, right? That we were trying to normalize and split the data into multiple tables. We might have put some data in one table and put some other data in some other table, right? But usually whenever you're going to display anything or you interact, usually you need to reconstruct the original data, right? You split it for storing, but usually when you consume it, you'll have to go and fetch from different places and reconstruct something. And this, to answer questions such as, give me all the blogs for a particular username, right? So here we're going to retrieve some data from the users table. We're going to retrieve some data from the blogs table, right? And we do that by join. We're going to join two tables, right? If you remember that there was first a cross product, and the cross product was to take all the users, right? Take all the blogs, cross multiply them, right? So you're going to have all the all the users combined with all the blogs, which makes no sense, right? There might be tons of users that are not associated with a whole bunch of blogs, right? So instead, we want to filter that cross product and only keep the ones that have a relationship, right? So in this case, the relationship is that blogs have users, right? That these are foreign keys, right, that refer to certain users and their IDs. Okay, so this is what join is, right? Join was a combination of a select, a cross product, right, and then a filter. So join does the cross product of these two, and then filters and only keeps the ones where the blog's foreign key is equal to the primary key of the other, right? So if we do that, right, and paste that here. There we go. So we have where the blog user ID. Okay, it's this one. Okay. All right. Let's see. What else? Then we're asking you to do it on your own. Do one join. I believe we ask you to join blogs and posts, okay, on your own. Then there's now this syntax here, this syntax of using the join keyword. I mean, it's fine when you're joining two tables, right? But when you start joining 3, 4, 5 tables, it gets really, really hard to read, right? Because you have these nested joins, right? Join the left table with the right table, which is not a table itself. It's a join itself, right? And then a nested join, and then a nested join. So it's really, really hard to read. So these syntax is referred to as an explicit join. Right? I'm explicitly telling you that I'm doing a join, right? There is an easier way to read this, right? A little simpler syntax, called the implicit join that achieves exactly the same thing, right? But instead of using the join keyword, we don't use the join keyword, right? We just say, we give you the two tables, and then we tell you how to filter it, right? We only want to keep the ones that have this equal to that, right? So you know, if you copy that, this should give you the same exact result as before, using an implicit join. Right? If you run it, it gives the same result. Okay. Notice that if we don't leave the where clause, right? If you don't have the where clause, look at the results. It's a really long list of all the possible combinations of all the users with all the blogs, even the ones that have nothing to do with each other. Right? Alice has nothing to do with SpaceX or Tesla or anything like that, right? And Elon, you know, doesn't have to do anything with hyperchange or anything like that, right? But the cross product gives me all the possibilities, of which only a few make sense. Only the ones where the foreign key is equal to the primary key, right? And that's where we put in the join, right? So if we put back the where, it filters out and only keeps the ones that are related to one another. Yes.
When you take out the join and just put like is that implied product?
It is a product. Yeah. Yeah. If you don't put it, yeah, it's very uncommon that you would do a cross product, right? It would always be followed by a where clause that filters out only the ones you want, or an actual join. Yeah, it's very uncommon. It's a very expensive operation, right? If you have thousands of records on one, you have thousands the other, then it becomes the cross product of all of them, and it's a huge, very expensive. It takes a while. Time and memory, yeah, it has to allocate all the space to consider all the possible combinations. Yeah. All right, let's see. Let's continue. All right, so and then we can combine both. We can combine the join part. Yes. No, they're equivalent. Yeah. You can combine where clauses, right? That are basically joins, right? This is a join right here, with predicates, right? Where a predicate might not have anything to do with foreign keys and primary keys. You're just filtering further, right? And say, okay, well, I want the employees that are in this department because there's a one-to-many or one-to-many between departments and employees, right? So and so that would give me only the employees within a particular department. That's a join. And then further, I can say, oh well, the ones that were that make between 100,000 and 200,000, right? And so that's not a join. I'm just filtering, right? And further say, well, the ones that were hired this year, and the ones that whatever had a bonus or whatever, right? And I can keep adding non-join, just predicate additional ands and ors, whatever, right? Whatever predicate. But one of them might be an exclusive joining the two tables or three tables. Okay. So now typically you have to be careful, right? That for every two tables, right? You should have at least one join. So if you have two tables, you should have one join joining those two tables. If you have three tables, you should have two joins, right? Joining table A with B, and then with B and C. Right? If you leave out one of the joins, again, you're doing a cross product, right? You're doing a cross product with whatever the additional table is there, right? So you should always count that you have at least one less join than how many tables you have. If you have four tables, well, there should be four joins. Four tables, you have three joins, right? Okay. So yeah, so this one just filters out that I only want those users and blogs where the user is Elon. Here, okay, well here's another one, right? I'm joining three tables, right? Where I'm joining users, blogs, and posts. Okay, and I have my two joins. See that? I'm joining first user with blogs, and then I'm joining blogs with posts. Right? So from user ID, I can navigate to blog user, right? And then and then once I have the ID of the blog, right, I can navigate down to the post, right? Because they have all foreign keys. You have the blogs user is a foreign key to the user, and then the blog the post blog field points back to the blog. Right? So these are all foreign keys pointing to the primary keys of their parents. Yes. Okay. So again, so these two are my joins. I have two because I have three tables. Perfect. Right. If I leave out one of these, it'll do the join on this, and the result of this will be cross product posts, right? Which I don't want. Right. So if you see a lot of results come back, it says, wait a minute, why did it so many? I didn't expect so many. You left out a join somewhere. Okay. And then obviously you can filter out with the everyday asterisk and whatnot. Okay, aggregation. So aggregation, as you remember, aggregates allowed you to create categories, right? And group records that came back into different buckets of categories, right? So in this particular case, where from the ratings, what we're doing here is that the ratings have foreign keys to the post, saying I am rating this post, and a particular post might have hundreds, thousands, well maybe not so many of likes or dislikes or ratings, how many stars, whatever, right? People might have liked or disliked something from the post. Okay, so we want to retrieve all the ratings, okay, and we want to group them by their post ID, right? Meaning we want to create buckets, for every post. Okay, and so we're going to say, okay, in this bucket we're going to dump all the ratings for post number 1, and in this bucket all the posts for rating number 2, and so on and so forth. Okay, once we have those buckets, we can aggregate each bucket and say, well, okay, bucket number 1, I want to add up all the likes that are in there, right? So we can say sum up all the likes. And this died. Just a second. Can you hear me? Can you? Oh.
Yeah, I can.
You can? Okay, good. Thank you. What was the thing? Right. So yeah. So if you look at the ratings table, real quick. Ratings. Okay, what we have here is, let's see, we have the primary key, we have likes, we have scores, comments, user ID, post ID, right? So these are all the posts. So we have 1, 2, we just have 2 posts, not too many posts. And so post number, so let's sort it by that. So we have half of my ratings are for post 1, a little over half the ratings are for post 2. Yes. And for post 1, I have 3 likes and 1 dislike. And we have a score of 3, 4, 5, 5. We have who the user is. Okay. And for post number 2, I have 1, 2, 3 dislikes and 1, 2, 3, 4 likes. Okay. And for here, I have 4, 4, 5, 4, 5, 3, right? Those are all my scores. Okay, make sense? So that's what we have. And so the question might be, okay, well, I want, if I want to calculate, I'm displaying all my posts, and I want to show how many hearts you have, how many likes you have. Well, I need to count them. At some point, I need to say, oh, you have 372 likes. Okay. So how do we do that? Well, we can create these buckets, right? And say, okay, aggregate all these, right? For post number 1, aggregate these and come up with 3, right? 3 likes and 0 and 1 dislike, or this would come up with 4 likes
Okay. Same thing here with the score, right? For post number 2, we might have so many scores. We would like to maybe average it out, right? 4 plus 4 plus 4 plus 5 plus 3 divided by 5, and that's your average score. Yes. Right? Well, group by allows you to do all that. Group by, create the buckets, and then ask, okay, add them up, add all the likes, right? And then average all the, average out what are all the scores, right? And then give it to me and display on the user interface. Make sense? So that's what group by allows you to do. Okay. So if we run that query here, and we paste that somewhere, I think it was here. And we run that. Okay, it looks like post ID 1 has 3 likes and post ID 2 has 4 likes. And I believe that is correct. Let's see, post number 1 has 3 and the other one 4. So yeah, we have 3 and 4. Makes sense. Okay, it knows how to add. SQL knows how to add, right? So same. I believe what I ask you to do is go ahead and use average for the scores on your own. Okay, just to practice on using group by. All right, then we have inline views. So inline views allows us to nest select statements, right? Nest select statements, right? And so it allows us to do the following, right? Notice the outputs. Whenever we do a query, right? Whenever we do a query, like this one, we just did this query, right? Now this data is the result, is the answer to this query. Make sense? And it just displays it for us. Once it's displayed, it's just for our visual consumption. But what if I would like to use this output for further questioning? Like I would not like to say, well, who has more likes? Right? And the answer is, oh, well, post number 2 has more likes. Or what is the average number of likes? Okay, well, it's 3.5. So I could further use this output as an input for further questioning. Make sense? So ideally, I would like to be able to use this select statement in a larger select statement. Like every select statement is like a question that we're asking the database, right? And the output is always going to be in the form of some tabular format like this, right? Or also as just a single value as well, right? We can ask it for a tabular answer like this. Or it can be just a single value as well, right? But if it's a tabular value like this, right, we could treat this as if this were an actual table. It looks like a table, right? It's not actually stored anywhere, right? The post table is actually stored. It has a whole bunch of rows and records, blah blah blah. But this is just a transient data that was generated. It spits it out. It's gone. Right? It's only for our consumption, right? But if we could grab it, if we could put parentheses around it, we could treat it as if it were a table, right? And so the next exercise asks you to do that. Right? Notice that we have an outer select statement, right, that has that is retrieving data from the blogs, data from the posts, and a table that doesn't exist, right? So this is a table, and this as if it were a table. See that? Okay. So we're taking the output of a select statement, the sum, which we just did, right? The sum that we just did earlier. We're putting in parentheses, giving it a name, right? Now we can treat this as if it were just any other table. So this would read, select that from table blogs, posts, and inline view. Yes? Right. And then obviously, just like we have to join blogs with posts, right? We're also going to have to join with the table that we were just created with inline view. So there has to be something in inline view that we can join with, right? And indeed we have. I think we have the primary key of the post ID, right? Post ID gives us post number 1, post number 2. That's the primary key. And indeed we do that, right? We say inline view. There's my join. See that? My inline view post ID is equal to the posts ID. So this table and that table are being joined together. There it is. And then blogs and posts are also being joined together over here. See that? Right? So there's 3 tables, right? You know, 2 real tables and 1 virtual table. Okay. And so I need two joins. Make sense? Yes.
The order in which you join matters.
No, doesn't matter. Well, for performance, it is executed from left to right, and so you should try that the earlier joins generate the less amount of data for the additional joins. So the first query should reduce the search space as much as possible, right? And so you would do things like things that deal with primary keys more than foreign keys, right? So that gives you more unique answers than broader queries. We'll talk about performance, but if you do bigger answers first, right, then you have to iterate even more later queries, right? But if you filter out your answers first, right, then you do less. It's like if you're going to do iterate over 2 arrays, right? It's better to iterate over a smaller array first, right, instead of a bigger array. Right, so same kind of deal. So yeah, so for performance it does matter, but functionally doesn't. Okay, so these are called inline views. Inline because it's being declared right here. Right? It's being declared right inside within the outer select statement. But we'll see later on in the next assignment that we can actually make this view, this select statement. If you notice that this is such a useful query that you keep using it over and over in a whole bunch of places, right? You can create an actual view. You can say, create view, just like you can create a table. You can say create a view called, whatever my favorite view, right, and give it a select statement. And then that view you just created, you can treat it as if it were a table. It's not a real table. It's really a select statement that gets substituted in there, right? And it runs every time, just like this runs every time. The select statement, this inner select statement runs every time. But if it's so useful, especially if it's a fairly complex select statement, right? You don't want to just copy and paste it every time, right? You can just give it a name and just reuse it over and over. Make sense? We'll take a look at the views a little later. Yeah, so just provide the file that you just been working. All right, any questions? All right, so let's get back to these slides. The slides are basically going to introduce a lot of these what we just talked about, joining and implicit joins, explicit joins, inline views, nested select segments. So we're just going to go over it. The slides just go into a little more detail, but basically it's what we also group by and all that. All right. Okay. All right, so SQL queries, I believe we had gone through most of this. Select, case, from, let's see how far we got.
I think we ended up equivalent if expression.
Where is it?
Equivalent if expression.
Equivalent if, okay. Oh, this one right here, yes. Right, I think we were just going to start from the from. Thank you. Right, so we spent quite some time in the select, right? Let's spend some time in the from. We already introduced it a little bit, but let's spend some more time there. Right, so here we have an example of a cross product, right? Where we have student S and department D, right? That's a cross product. Right, it's looking at our 9 students multiplied by 3 departments, right? And that gives us 27 combinations, of which a lot of them might make no sense, right? Because most of the students are not in all departments, just in one or fewer department, right? So first of all, let's talk about the fact that whether we put a prefix or not, right? If there's no ambiguity, then there's no reason to put a prefix. Now, in there's some cases where, like the example we saw earlier about self-referencing, that renaming a table is handy, right? So, for instance, if you have if you're retrieving data from the same table twice, right? Obviously, it's going to have fields that have the same exact name. So you have to prepend in front of the field whatever you want, even if the tables are not the same. Right? With table A and B, the two tables might have the same field names, right? And you want to make sure that that you retrieve what field you mean from which table, right? Now the cross product, right, returns all possible combinations. Instead, usually what we want to do is only return the ones that are related, only the records that are related, right? And that's what we use join. Right? So join is a combination of doing a select, of doing a cross product, right, and then doing a filter. And so this join is first doing the cross product between these two, right? And then applies the filter, saying no, I only really want the ones, but the foreign key of one of them is the primary key of the other. And so in this case, it would return the only the students that are in a particular department. Okay. Now, there's several types of joins. Okay. The most common join is this one, right? Where you just give it the two tables, you join them just normally, right? And they give the foreign key, primary key. Yes, that is the most common type of join. We call it the natural join. Is what you normally think of a join, right? Of retrieving data that is related. So that was the whole point of inventing this in the first place, right? So we call that an inner join or natural join, right? That's the jargon here, right? Inner join or natural join. There's two terminologies for that common type of join. There's also a left outer join and right outer join. Okay, that by left and right we mean that you from the join's point of view, you are either referring to the left, right, or you are referring to the right, from the join's point of view. Okay. So let's take a look at each one. So we already looked at inner join, right? It only retrieves the records where the foreign key, where the predicate is true. Yes, it only retrieves the records where the predicate is true. And that predicate typically is some foreign key equal to primary key. What about all the records that didn't meet that predicate? Do we want them? Typically not, right? If you do it's kind of say, well, they're not related. Why would you even bring them, right? The records are not related. Why would I even care? Well, left join and right join allow you to say, okay, do the join. And all the other records that did not meet the criteria, right, bring them in as well, right, from either one. If it's the left join, means if there were records that don't meet the criteria, well, bring the rest of the records from the left table anyway, even if they did not meet the criteria. Or the right join is same thing, right? Bringing all the ones that meet the criteria. But even if but also bring the ones from the right table, even if they didn't meet the criteria. Right? Why would you ever want to do that? Okay, let's take a look at a couple examples on why would you want to do that. So first, let's look at the inner join. And so here we have three folks, a couple of orders, and we have Boone, Dole, and Garcia. We have PIDs, person IDs, 1, 2, 3, and here are their orders, right? And we see that they were generated by 2 by Garcia, 2 by Boone, right? And 15, it's a foreign key of a person that doesn't exist. Okay. Okay. So let's join these. So if you join them, it's like it will return to me all the persons and orders where the foreign key is equal to the primary key. That's easy, right? Here are the 2 orders by Dan, and here are the 2 orders by Charlie. Makes sense, right? That's just the normal inner join. Yes.
I'm just going to say on the last slide, why you didn't give the non-existing person a number?
So this is to make a point of this is pointing to something that doesn't exist. Okay. not that you would ever allow something like this. It's an order that's orphaned, right? That is pointing to a record that doesn't exist, right? Again, with if you have referential integrity, this will never happen. Right? So somebody screwed up, right? And they allow you to have allow us to have a record that doesn't have a parent, right? But we would not allow that because we know that how to avoid that, right? By making referential integrity. But it will allow me to make a point in a second.
Okay, sorry.
No. So yeah, so these are the two orders and the two users that meet our inner join, right? Our natural join. This is what you would expect, right? Only the records and users who are related to one another. Okay. All right. So let's take a look at left join. Right, so left join says, from the point of view of join, right? If I say left join, says that, well, first of all, give me the ones that meet the criteria. Whatever column in table 1 is equal to table 2 in the column for table 2. Okay, return all those. But what about all the other records that did not meet this criteria? Well, left join says, in addition to the ones that meet the criteria, bring me all the ones from the left, even those that did not meet the criteria. Right? And somebody might scratch their head. Well, why? Why would I bring stuff that is not related? Okay. And so, for instance, this would be in the case if we go back to our original database, it would look something like this, right? I do the join, and the person is on the left. See that? Person's on the left, and Boone and Charlie had records that met that were counter records on the orders, right? But Garcia didn't have any, right? Garcia didn't make any orders. Yes. Well, I'm bringing Dole anyway. Okay, and there is my result. Notice that I have no order because there is no equivalent order on the table. One might say, well, why would I want that, right? This is going somewhere. Okay, and there's a crescendo. Okay, so here's an example. So here's an example that says where you might have two tables, right? And there's a staff that is working at the university or a particular company, right? And they have a social security number, first name, last name, and then there's in another table we have the spouses of the staff. Okay, now not everybody has a spouse. Okay, not everybody has a spouse. And so I want to send invitations to a party, and I also want to invite the spouse of the employee, right? I want to invite the staff and their employee and their spouse, if any. Okay, if I just read, I want to invite the employee and their spouse. That means I'm going to have to join the staff and the spouse information, if I want to print the invitations correctly, right? You want to send them out. Notice that in that join, it will only return to me, right? Only those staff that actually have a spouse, right? And so all the other staff that don't have a spouse would fail that join, right? That means that those that don't have a spouse would not be invited, right? So in those types of queries, you might want to retrieve the information even if they don't meet a particular join. Make sense? Right. So in those particular edge cases, you would have to read it carefully. If it just says invite names of a staff member and the spouse, well, then that's just an inner join, right? But if they add additional requirements such as if any, meaning okay, so if they don't have a spouse, they should still get invited. Okay. So you have to be careful, right? In those edge cases, you might need a left join or a right join to bring in the data, even though they might not have records. Yes.
Do you have another example of like when this is used for
no. No. Well, I mean, no. The point is that there are cases, right, that you want to retrieve, orders that were left out, right, that were orphaned like we had before, right, and I want to do a statistic on them anyway, right, and retrieve, or you might just want to see if they have a relationship, right, but I don't want to bring the information, I don't want to retrieve the information, I just want to see if there is a relationship, right. Yes.
So there's a left and right join, right? So like.
Yeah, it always just for convenience of how you're writing the tables on the left and the right, right? It's relative to where the join is, right? Either on the right or the left.
And these are called out.
They're what?
They're called outer joins.
Yes, right, outer joins, yeah. Yeah, it's called left outer join or right outer join. And outer join meaning the ones that don't have references, that they're not related, right? And the most expensive outer join is called the full outer join, right? Which is basically a cross product, right? It's a cross product that says I'm considering every relationship with the other one that usually that might not have any meaning. Now that definitely has no meaning. Yeah, so the inner join would not be enough. It would be leaving. It would be those staff that don't have a spouse would be left out. Yes.
And outer join on staff would have been set. There would only be any spouse would also have staff.
Say again.
An outer join on spouse would make sense because every spouse.
Well, every spouse will have a staff. Right. It would make no sense, right? Yeah. Yeah, this is an outer join on the staff, not on the spouse. Yeah, so here we're doing a left join on the staff, right? Because I want all the staff, even if they don't have a spouse. Right join is just is that, you know, again for convenience purposes, right? If the table that you want to retrieve from is on your right. Okay, so for instance, if you do this too, you're retrieving all the orders, but not necessarily the users, because you know Dole didn't have any records that met the order, so it was being left out, right? But you want to bring in the orders nevertheless. And a full join, right? You just you want to retrieve from both of them. Now you retrieve both all the records from that first, the records that have a match, and then the remaining records that are left out. Okay, so when you're specifying more than just one table, right, this starts to get hard to read, right? Where you're doing a join between tables, like student and enrolled, right? And you do the primary key, foreign key that joins the two tables, and then if you want to join on a third table, like first the student with enrollments, right? Because remember, enrollments have a foreign key to the student, right? So you can do the foreign key student ID with a primary key of the student, right? That's a join on this too. And then once you have the subset of students that are enrolled, okay, now we can do a join of those records with the section. We join it with the section where the enrollment, you know, the enrollment section ID, okay, section ID. I'm sorry, E section ID is the foreign key to the primary key of the section ID, right? So we're joining on there. Now this starts to get really hard to read very, very quickly. Okay, with putting all these parentheses and just expanding, it's nested, right? It's hard to read. So when you have 2 or 3 more joins, the alternative is to, instead of using this syntax, you can use an equivalent syntax, right? The implicit notation allows you to write something that is a little harder to read in terms of just a plain where clause. Okay? So instead of using an inner join, department on, right? You can just do a where, right? The foreign key equals to the primary key. Okay, so it's an equivalent. So this is referred to as an implicit join notation, and the other one the explicit join notation. Right. All right, so let's spend some time on the where clause. Right, so it allows you to filter basically, right? It allows you to provide a predicate or set of predicates, right, that have to be met. It's basically one big Boolean operator, right? Lots of ands and ors that are nested together. That have to be true. If it's true, then the record it will be selected. So basically, remember the select statement is basically an iteration over a data set, right? Which is your table, and as it's iterating over your data points, right? It's evaluating this predicate against each one of those records, and the records that meet the this criteria are selected as a result. Make sense? Right? So yeah, so the where clause allows you to do comparisons, right? Basically write a Boolean operator, right? Boolean expression where some field is equal to another field, and some other field is greater than some other field, or some field is less than some other field, right? So you have all sorts of operators that allow you to compare somehow these fields, right? So equal is just a single equal, not the double equal, right? The not equal is two, it's a less than and greater than sign, not the bang equal, right? Careful. Then you have to just your normal greater than, less than, less than, and so forth. Between allows you to do range comparisons, right? If it's between some minimum value, some maximum value, right? Inclusive. And like allows you to do regular expression with strings that meet that pattern. Right? And in allows you to do comparisons on a scalar values, right? That you can provide certain values that it will compare against, right? And whatever meets that criteria, it'll be selected out. So let's take a couple of examples where you're here. We're selecting, from these users, we're retrieving the persons whose city is equal to Lowell, right? And so strings use single quotes, not double quotes, single quotes. And so this retrieves these two records, the ones that have Lowell. And you can mix them, make more complex queries, right, by using ands and ors and parentheses, what you would normally do to implement just regular expression. I mean, Boolean expression, right, with parentheses, with the same rules that you would expect in any Boolean expression, right? So this one's just saying, give me the persons whose first name is Bob and last name is Dole, right? Just give me that. It gives me that one person. The or, right, means that any one of these sub expressions is true, then I take out that record out. Right? So here, is it Bob or Dan? I retrieve those two. Okay. And you can combine ands and ors and nots, together to make ever more complex Boolean expressions. Multiple joins are. Oh, right. Yeah. So. Oftentimes, when I had mentioned earlier, right, that when you have multiple tables, right, that you're going to have several joins, right? It would be hard to read. It would be a challenge to read this, right? So you can always rewrite it into an equivalent set of Boolean expressions, right, where the foreign key of one is equal to the primary key of the other, right, and using the and to just add to that to the join. Okay, so this join here would be this equivalent Boolean expression here, and then another join would be an and on another Boolean expression, both of them doing joins, right? And so that's the example that we saw in the assignment, right, where we have two joins here, right, using the implicit notation. You can mix and match some predicates that are specific for the join, right? That filter out by foreign key primary key, like these two in red, mixed in with other predicates that have nothing to do with primary key, foreign key, right? These are just filters on non-key values, right? Like the name is Joe, the year offered is whatever, right? And so there's you can mix and match. Between allows you to provide values that a range, a minimum and maximum. You could use numbers, right? Floating point values. You can also use characters or strings. Okay, and then you'll use the lexical value of the string to see if it's within a particular range of strings. Right. So, for instance, the last name between this character, this string, and that string. Right. So it'll fetch a record whose last name is lexicographically in between these two strings. You can use strings or you can use numbers as well. And so to do ranges, or you can use the not operator, right, to do the inverse, so not between. And allows you to provide any number of enumerated values by which the field is going to be compared against, right? And so the values, what it'll do is it will iterate and compare your column against each one of the values, right? And when it finds the value, if it's true, if it's there, then it chooses that record. Now, operations are considered expensive, right? Because as it's iterating over the records, then for each record, it needs to iterate over all the in values, right? So they're much more expensive that it has to be compared against, right? So if you can avoid them, the better, right? But they're there. So here we have two values numbers here. These could be numbers. They could be also characters, strings, dates as well, right? And it'll compare the field with every single value. If it matches perfectly, then the record is chosen. So these two meet that in criteria. Like allows you to do regular expression matching, right? Where it'll compare a string against a pattern, right? That starts off with a character and then percent allows you to say, well, anything that starts with a J, right? It follows the number of characters, 0 or more characters. And you can also use underscores for a single character, right? And so you can do a combination of single characters, multiple characters, right? These are also very expensive, right? So any pattern matching, you would try to stay away from, but if you need them, it's there. But in general, they are considered to be expensive. Ideally, you would have a starting character, set of characters fairly long, right? So that you can quickly throw away tons of field records that don't match, right? But the smaller this is, right, the more general, the more expensive the comparison will be. Right? A current user, you can as I mentioned earlier, you can reference the person that is currently logged in, right, and have queries that are based on the username of the person who's logged in. So I can retrieve the courses or sections or students that I'm teaching, right, based and some other faculty can use the exact same query, and they'll get information about their particular courses, their particular sections, their particular students, based on the current user. All right. Let's talk about subqueries. Yeah, subqueries, as I mentioned earlier, you can have all these queries be nested inside a bigger query, right? You can just put a parentheses around it, right? You can give it a name, and then you can treat it as if it were a table. It's not a real table, obviously. Right? And you can use subqueries in several places, right? Depending on what you expect. So nested queries can be used in different places. It can be used in the where clause, right, in the from, and also in the select, right, in different places. So, but depending where you use it, then the subquery needs to return what you're expecting. Okay, like in the from clause, it's totally fine to return, rows that have many fields, right? That's totally fine because the from clause is expecting a table. Okay, but if you're using it in the where clause, right, or in the select statement, right, usually those are expecting just a number because you want to compare against something that is greater than or less than, right? Or if you're using in the in, right, then the in is expecting a list of values, right, of individual values. Okay, so depending where you're using this nested query, right, you need to return whatever the operator is expecting, right? Again, from can expect an entire table, right, with records. In the where clause, right, it depends, right? If you're saying, age greater than, well, you're expecting an integer, right, a single integer, right? Okay, so that your select statement, your inner select statement needs to be able to evaluate a single value, a single scalar value, right? But if you're saying, age in, and you want to parentheses all the ages that you want to compare against, well, then you're returning multiple scalars. Yes, not a table, multiple, like an array. Okay, so again, it depends where you use it. The nested subqueries need to make sure that it returns that. Okay, so here's an example of an outer select statement. Okay, and you have a from table one where table one dot field in, see in, right? So notice that this select statement is where it's in the where clause. Okay, and it's being used, whatever the select statement returns is being used in the in. See that? And in is expecting an array of things, right? Either an array of strings or an array of numbers, right? Because it wants to compare field one with an array of things. Okay, so this inner select statement can only have one field in the select statement. See that? You can't have two fields. It would make no sense, right? Okay, it can only retrieve one field multiple times, right? It can retrieve different values for field two, right? That meet this criteria where field two is greater than whatever value two, right? And then these values, right? So this might come back with values 1, 2, 3, comma 2, 3, 4, comma 3, 4, 5, right? And this collection of values will then be used to check to see if field one is equal to any one of those values. Make sense? But it makes no sense here to have two fields, field two, comma, field three, or star, right? Because then that would be three scalars, comma, three scalars, comma, three scalars. But field one is a single scalar. You can't compare one single scalar against three different scalars. Makes no sense. Make sense? Right? Now, if instead field one was an integer, right? And you would say, if some integer is equal, then on the left side, this needs to evaluate to a single integer so that you can compare them. Yes? Right? So your query needs to make sure that it only returns a single value. So it depends on how you use it, but you have to be careful that the inner select statement returns what your outer expects. Make sense? So for instance, here's an example, right? You might have a query like this where you want to return all the students and the details where the first name is Alice, Bob, and Charlie, right? So this is a query that you might have, right? And you hard code those values, right? Alice, Bob, and Charlie. But to make it more generic, right? Maybe next semester it needs to be a different set of students, right? These are my best students, and I want to for a party, whatever. For the dean's office, they want to dean's list, and I want to make sure I keep them around, right? And so, but next semester presumably it'll be a different set of users, right? A different set of folks. Yes. So instead of hard coding these values, it'd be great if I could generate this dynamically. Put a select statement that returns a set of strings, right, from a student table. Right? But I got to make sure that it only returns, a string, comma, string, comma, string, right? So to do that, I can use an inner select statement. An inner select statement that filters out the students whose subject is science, right? And I got to make sure that the fields that I retrieve is what the outer one expects, right? It's trying to look and compare first name in. And this needs to evaluate to a list of first names. Right? So I got to make sure not to include the last name, right? And date of birth and other stuff that the outer one does not expect, right? So this creates a list of first names that I can then use to compare against. Make sense? Right. Here's another set of queries where we have some statistical values on population and GDP and blah blah blah. So you might have a query saying, list the countries with a population larger than Russia, right? Well, there's a couple things that need to be calculated. Well, I want a list of countries, right? I need to have the population of Russia, right? So first I have to go fetch the population of Russia, right? I have to calculate that, right? So an inner query might do that for me, right? It says, select population from the GDP table where the name is Russia, right? And that evaluates presumably to a single value. Just notice that it's being used against a comparison of some number, right? Notice that I'm saying select name from GDP where population is greater than, right? So this comparison presumably is comparing numerical values, right? So the left-hand side is population, it's an integer or float or whatever. It needs to be compared against, and it's also something that's float, right, on the right-hand side. So I have to make sure that the right-hand side evaluates to something that's comparable. Otherwise, I'll get syntax error or whatever, right? So here's another example, right? In the previous one, this was like an in, right? The population or whatever was in, and I was expecting an array of things, right? Here, I'm expecting a single value. And indeed, my select statement evaluates to single value. But it would make no sense for me to do select population, comma, something else, right? Makes no sense. This is only that. Now, obviously, this I would make sure that this inner query also evaluates a single record, right? So it has to be a single field and a single record, right? To just one field, right? Then presumably Russia is unique enough, right? That this indeed just returns a single record with a single field. So yeah, all right. So that's in the where clause. So in the where clause, typically you retrieve either an array of values, right, or a single value, so that you can compare it, right, whether in the in or compare against a field. You can also use the inner subqueries, right, inside the from clause. Right? So we saw the where, we just saw the where, a couple of examples. You can also do it in the from. Now the from is a little more forgiving, right? It allows you to retrieve not just an array of values or scalar. It allows you to work with entire tables, right? Entire set of records, and each one having a whole bunch of fields, right? Right. So you can work with an entire table. And so this select statement, it's doing a group by, right? So it's from the table, the orders table, right? So it's iterating over the orders table. It's grouping by the supplier ID, so it's creating each a bucket for each supplier, right? And it's putting in those buckets. It's putting the supplier ID, and then for each one of those buckets, it's adding up all the amounts for the orders, right? So at the end, you're gonna have a whole bunch of amount added up, for each one of the suppliers. Make sense? Okay. And it's renaming that field of the added values into a total amount. Okay. So at the end, you're gonna end up with a whole bunch of records, one per supplier, right? Because that's how they were grouped, right? By bucket. So if you have 4 suppliers, you'll end up with 4 buckets, right? Each one with a supplier ID and comma the total amount. Yes, so 4 records that have those 2 fields. And this table with 4 records and 2 fields, I'm gonna name it internally. I'm gonna name it subquery 1. Now I can treat subquery 1 as if it were this little table, right? 4 records, 2 fields, along with suppliers, right? It's going to do a cross product between these 2, right? It's going to do a cross product of which I don't want all of them. I only want the join down here. See that? I'm joining the subquery that has the primary key of the supplier ID. I'm joining it with the suppliers over here that has presumably some foreign key. Yes? Right? So I'm mixing, I'm only keeping the ones that match, of which I retrieve from the suppliers table. I'm retrieving a field in the suppliers, and from my inner, I only have 2 fields, right? I have the supplier ID and I have the total amount, of which I am displaying the total amount. See that? So from the subquery 1, I can only retrieve what? Supplier ID and the total amount. That's the only 2 things that I have in that table, right? Those are the only 2 fields in there, right? So I'm displaying the total amount over there. Make sense? Okay. Yeah, so this is referred to as an inner, an inline view, right? And again, we'll see a little later that if this is so useful because you're using this over and over in multiple queries and everywhere, right? Might as well give it an actual name, right? Just like an algorithm that you find very useful, you would put it instead of a function, yes? And then that function, you could use the name of that function, you can use it elsewhere and reuse it. Same thing here. Views allows you to abstract these kinds of queries. All right, so yeah, so we can use subqueries in the where clause, in the from clause. You can also use them in the select statements, right? Instead of the select. And so in the select, right? In the select, it always has to evaluate to a single value, right? It cannot be an array, it can't be a table, right? It has to evaluate to a single value, just like in the where clause, right? In the where clause, it can be an array, or it can be a single value. Well, here it can only be a single value. Okay. And for instance, what we're doing here is that we have a where clause, right? We have a from, blah, blah, and notice that we're doing a count, right? And a count, we know it's going to aggregate the entire table, right? And just count and evaluate it into a single value. Right? And notice that we don't have anything else. We don't have count, column name, comma, something else. No, just that one thing is evaluating to the count. We are giving it a name, subquery 2. Right? So this will spit out, right, three things, right? The owner, the name, and the subquery 2. Okay. Union. So union is an operation, very common operation, where you might want to bring together values from multiple tables, right, into what it might look like a one single resulting table, right? And so so it's just like a copy paste, and it allows you to combine the results, the output, the either table 1 and table 2, or 2 select statements, right? One select statement that fetches some information and another select statement that fetches some other information, and together you can put them in one single outer single set, right? The one of the things that we have to make sure is that the names and the data types of both need to match, right? Otherwise, if column 1 from the first query is an integer, and also column 1 from the second is a string, right? It'll look funny, right? Where you have half of the columns are integers and and later on down below it's a string. It makes no sense, right? So you have to make sure that the column names are the same and the data types of the columns are the same, right? So here's here are 2 tables. You have a EID, ename, and the other one. So that's in Canada, and then the employee table in USA. It's spelled differently. EMP name. You know, on purpose, I made them different. If I want to make a union out of them, I have to make sure that the column names are the same, right? In the output. The data types are the same, so I don't have to deal with that. I'm okay with that. So if I want to make the union, right, I would do something like this. Select all the names from the Canada employee, a union with the employee names of the employees from USA, right? So just to make sure that they fall under the same column, I either rename the column from the Canada table, or I rename the one from USA, right? We chose here to rename the USA field to ename to match the name for the Canadian employee table, right? So that they fall under the same output column, right? Otherwise, you put them in different columns, right? And separately. That makes no sense, right? Also, by default, if there is a repetition, right, where one value from one of the tables has the same value in the other table, right, it'll skip it, right? So if it has duplicates, it'll by default will skip it. If you do want the duplicates, then you explicitly have to say union all. Give me even the ones that are duplicates, right? And you might have duplicates just because this might be a foreign key, and foreign keys are okay to have duplicates, right? Right, that they might have the same role, they might have the same title, they might have the same whatever, right? And you might want them or not want them. Yeah, so if you want the repetition, like for instance, Dole, Stephen, is working both, is registered in the Canadian office and in the US office. So it's shown in both cases. And here in this case, we want them both twice. Okay. Order by is used for sorting, right? And sorting the outputs, right? So that when I ask for the records that are coming out from the table, I might want them to display in a particular order. Okay? It doesn't reorder the actual data underneath in the table, right? It's only for presentation purposes, right? I want to see it ordered by last name. I want it ordered by dates, or I want to order by whatever, right? You should never assume that the date itself, the information underneath is ever ordered in any particular way. Okay, the database, obviously internally it does restructure the data for performance purposes, right? But you should never assume that it's in any particular order. So you can say, at the end of select center, you can say order by, and then the column names separated by commas, right? So column, comma, comma, new column, and so on and so forth, right? And you can, by default, it does an ascending on that column, but by default, if you want it by descending, you can explicitly say descending, right? Right, so here's an example, order by last name. Again, by default, it does an ascending. So Boondle, Nielsen. Again, only for display. The data is still ordered as before. Or if you want to descend it, you can explicitly say descend. All right, we'll leave it here. We'll come back and finish up on Tuesday. All right. If you could read on the rest of the slides so that we can finish it up when we get back. All right. All right, awesome. Have a great weekend.
Thank you, Professor.
Bye, everyone.
Just because I looked at the code for this upcoming